Hello friends, in this video we are going to prove that packing fraction for simple cubic structure and for body centered structure are respectively 0.52 and 0.74. Okay, so now you see, actually for body centered it should be 0.68, okay, not 74. 0.74 should be for face centered cubic lattice. For face centered cubic lattice. For FCC it should be 0.74. Let me show you how to do. Now you see, for SC simple cubic structure, right? For SC simple cubic structure, for simple cubic structure you say number of atoms per unit cell is 1, because you see, suppose this is a unit cell for simple cubic structure. So each corner at each corner we have 1/8 part of this atom, right? Because you see, if there is a atom, this one, so it consists, this atom is shared by 8 unit cells, okay, 8 unit cells, because upper part of this atom will be shared by 4 unit cells, such 4 unit cells, okay. The upper part, the upper half will be shared by 4 unit cells, okay, this upper part, okay. If you see the upper part from the top, then it will be shared like this: 1 unit cell on this side, and 1 on this side, another on this side, okay, another on this side, like this. It will be shared by 4 unit cells, the upper half, and the lower half also will be shared by 4 unit cells. So that's why at each corner, there is 1/8 times of one atom, okay. Each corner consists that 1/8 times one part of 1 out of 8 parts of the atom, right? So if that is the case, there are 8 corners, so number of atoms will be 8 into 1/8, that's going to be 1, right? So hope you have understood this. So now volume occupied by the atom in the unit cell, and if we consider each side of this unit cell is suppose A, then the radius of the atom is, so radius of or atomic radius, or you can say atomic radius R is equal to half of the edge of the unit cell, right? So then volume occupied by the atom, that's going to be equal to 4/3 pi r cube. Only there is one atom, so it will be 1 into 4/3 pi r cube. That means 4/3 pi r cube. So volume of the unit cell, that's going to be equal to A cube, right? So packing fraction packing fraction, that packing fraction will be given by the volume occupied by the atom 4 by 3 pi r cube divided by the volume of the unit cell, that is a cube. So 4 by 3 pi, instead of r we're going to write a by 2 whole cube, right? A by 2 whole cube divided by a cube. So here 4 by 3 pi, so a cube by, that's going to be 8 divided by 8, here we have 8 cube, so a cube cancels, so what we have 4 by 24, right? That's what we have got. Sorry, I missed the pi here, there should be a pi. Here is the pi, so that is 22 by 7. So in that case, so what we can do here, so it's been 6 times, then here it will be 3, here it will be 11, so 11 by 21. So if you divide it, you're gonna get approximately 0.52. okay, now take the screenshot. Now let us do it for let us find the packing fraction for body centered structure. Okay, body centered cubic structure BCC. So in that case, number of atoms will be changed here. So for body centered cubic lattice, that's number of atoms will be, first let me clean these things. Here radius will be also changed. Okay, so volume occupied by atom will be also changed. Okay, so now let me clean these things. So hope you have taken the screenshot. Okay, so now you see, in case of BCC, there is a complete atom inside the cube. Okay, inside the cube, right? And there is 1/8 of one atom at this corner, at this corner. So you can imagine the diagram like this. If you see the presence of the atoms in this structure, this view you're gonna have. Okay, this one, and this one, right? Like that. And there will be also one out of 8 part of the atom here also. So they must be touching each other like this. Okay, here is here you're gonna have 1 out of 8 part of an atom, and here you're gonna have a single complete atom, and here also at this corner also you're gonna have 1 part of out of 8 parts of an atom. Here also 1 out of 8 parts of an atom, like this. Okay, so if that is the case, then if this is A, right, then here you see, if this side is A, then consider this one. Okay, this side is also A, this side is also A, then this side must be root over A square plus A square, right? So that's why this should be root over A square plus A square, that means A root 2, right? If you use the Pythagoras theorem, this is also a right angle triangle in case of cube, right? If you imagine a cube, so if you apply the Pythagoras theorem, A square plus root over A square plus root over A square, that's going to be 2 root A square, under root 2A square. So square root of A square will be A, so A root 2, that's what we're going to have. Okay, so if that is the case, then again apply Pythagoras theorem here. Now take this triangle. If that is the case, then here you're gonna have a root 2 whole square plus a square, and that's gonna be equal to root over a square plus, sorry, not plus, a square into 2 plus a square, that's going to be root over 3a square. So that's why we will have this is equal to a root 3. Okay, now you see this is the radius. Okay, so here this is going to be the diameter, right? So this is the radius here, this is also radius, this is also radius. How many parts, how many radii are there? 4, right? Radius, 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 4. So that's why 1/4 of this will be equal to radius or atomic radius. Okay, so atomic radius will be a root 3 by 4. That's what we're going to have. Okay, so now volume occupied by atoms, 2 atoms. There are 2 atoms, right? So here number of atoms per unit cell is 2 here, because each corner shares 1 out of 8 parts of atom. So there are 8 corners. So that is 1 atom, and 1 atom inside the body also unit cell. That's why it is body center. So now volume occupied by the atom, right, that's going to be equal to 2 into 4/3 into 4/3 pi. Instead of r, we're going to take a root 3 by 4 whole cube. Okay, if you calculate this, 2 into 4/3 pi a cube into 3 by 4 cube. Here we're going to have 4 cube means 4 into 4 into 4. That's a 4 gone, 2 cancels, 4 gives 2, right? So then 3 cancels here. So this is going to give you, let me just write this one here. This is going to give you okay, sorry, this should if you cube it, cube of root 3, that should be 3 root 3. Okay, so that's why root 3 a cube by 8, 4 to the 8, right? So that's what we're gonna have. And also there should be a pi. Okay, pi a cube, that's what we're gonna have. Okay, so now volume of the unit cell is a cube, so that's why packing fraction, the packing fraction should be, let me write here, that should be root 3 pi a cube divided by 8 divided by a cube. So 8 a cube cancels. So root 3 is approximately 1.73. okay, and value of pi 3.14, and divide them by 8, then you're gonna get approximately equal to 0.68. that is the packing fraction of BCC. Okay, similarly we can find FCC also, packing fraction for FCC. So just take the screenshot. Okay, just take the screenshot. So now let me clean this. Let us calculate for FCC. So let me make it FCC. Okay, so in FCC, number of units, number of atoms per unit cell will be different, and the radius will be different. Okay, so that's why volume will be also different. So let me clean these things. Okay, hope you have taken the screenshot. So in case of FCC, atoms will be also on the face also, side, and at the center of the body there will be no atom. So here in case of phase center, what we will get, in case of phase center, we're going to have total one atom, combining the parts of atoms at corners, there is one atom, and each phase shared half of an atom. So there are 6 phases, so 6 into half, that's going to be 3. Total number of atoms, that's going to be 4. Okay. In case of FCC, there will be no atom at the center of the body. Okay, it presents in BCC only. Okay, so here you can see in this case, here half atom, here half atom, here half atom, here half atom, here also, and here also. 6 phases of this unit cell will share half of atom, and 8 corners will share one out of 8 parts of an atom, right? So hope you have understood this thing. So here the radius will be if you take the figure, this figure, okay, not this one. If you consider if you consider one phase of this unit cell, you can see this, that here should be 1 out of 8 parts of an atom, and here is half of atom. Again, here will be 1 out of 8 parts on the face. Okay, and this is radius, and this is diameter 2r, and this is radius. Okay, so total 4r, and that's going to be equal to 4r will be equal to, if this is a, this is a, that's going to be equal to root over a root 2, right? So that's why radius will be a root 2 by 4. So that is the radius. Okay, so hope you have understood this. So if that is the case, then radius will be what we have got now, a root 2 by 4, and here a root 2 by 4. So here number of atoms we have got 4, so let's put here 4. So 4 into 4 by 3 pi, here it will be a cube, then root 2 cube is 2 root 2 by 4 cube is 4 into 4 into 4, 2 4s will be cancelled, right? So that's what we have got. So what we have got now, volume 2 root 2 pi a cube by 3. Okay, so 2 4s cancelled, 3 4s are 12, that's what we have got. Okay, and there is so this cancels, it will be 6. Okay, and this a cube will be cancelled by this a cube, right? So if that is the case, then what we have got, then we have got root 2 pi by 6, that's what we have got. And if you calculate this, if you put the value of pi, root 2 and all that, then you're going to get approximately 0.74. This is the packing fraction for FCC, right? So hope you have understood this. Thank you for watching. See you in the next video.